Hi, my name is Rod Schultz. I'm head of product security and privacy at Zoom, and I'm joined in New York by Max Krohn, who's head of security engineering. Today we're going to talk about the rise and value of digital trust and the importance of identity. So a little bit more about myself. So I'm based out of San Francisco, California, and Max is out of New York, and we've been working together for the past six months on a project with Okta, and we're going to talk to you about some of the details of what we've been up to. So a little bit about the agenda. I'm going to start out and talk about the value capture of growth and what that means and why this project really has some value for what we're trying to accomplish between ourselves and Okta. I'm going to talk about trust and identity, how they're foundational to everything about what we're trying to pull off here with this project, and talk a little bit more about our trust strategy. Max is going to go into some of those details about how that works on the back end and some of the cryptographic aspects of what that means. And then I'm going to fit it all together at the end and show you how this kind of aligns with the strategy of where Zoom is going. So I'm going to start and frame the conversation with this. Over the last 12 months and a little bit longer, we've seen rapid growth in video conferencing. And you've seen some very interesting separation distance from Zoom and the rest of the pack. So the question that is brought up is, how do we capture and strengthen the overwhelming growth that these forces have generated? And what we're really attempting to do is we're trying to capture network effects. So what that means is, as network effects increase, you start to see more value, and it's based upon the number of interactions in the nodes. So you can see from the left, we have two phones, there's a single interaction between two nodes. But as we go to 5 nodes, we have 10 interactions, and 12, we get to 66. So the strategy here that we're working on is, how do we start to capture value, and how do we move from Zoom being simply a connection to Zoom becoming something more persistent and creating more value throughout the existence of the platform. So I want to talk about real identity and what that means as a foundation for this trust. If we look at current social networks and you kind of take a look at the value of those social networks, you can see that anonymous networks moving from anonymity to pseudonymity to real identity start to increase in value. That starts with Whisper and Yik Yak, who are in kind of a questionable state. That leads us to pseudo-anonymous networks like Twitter and Reddit, and you can see those valuations are pretty impressive. So Reddit is valued effectively at $6 billion right now because they're pre-IPO. Twitter is about 58 billion, give or take. But as you start to move into real identity, this is really where the opportunity lies. LinkedIn, acquired by Microsoft back in 2016 at a 26.2 billion valuation, and then Facebook really is what everyone is going after. How do you start to capture the opportunity that trust and reputation create as you start to move towards real identity? And effectively, this is what we're going after. So trust is the accelerator of performance, and when trust goes up, speed goes up, and the entire value of the transaction goes up. And the relationship that we're seeing, that we're building on top of with this opportunity with Okta, is that as we increase trust in this network, we start to see the value of the transaction move up. So let's talk a little bit about Zoom's strategy for trust creation. And that strategy started last year with the acquisition of Keybase. This is Max's company that was acquired to help create foundational trust for a lot of the transactions that are happening on the Zoom platform. So what does that mean, trust? Well, I think what it starts with is you've got to start to look at what the Zoom infrastructure looks like. The majority of people think of Zoom as simply audio and video exchanged between one laptop or one computer to another. But really, there's this massively powerful back-end infrastructure with data centers, clients, internal infrastructure, and public cloud connections that really start to create these high-speed audio and video tunnels that allow people to exchange information on Zoom. And one of the most fundamental core components of that is the Zoom multimedia router. So that multimedia router is responsible for hosting Zoom meetings. It's effectively the connection points for where people meet up on Zoom. And with Keybase, what Zoom has done is we've taken the multimedia router out of the key exchange process. So what does that mean? Well, let's talk a little bit about that. If we take a look at a typical Zoom meeting and what people think about, and we expand out, let's see what happens when two people decide to meet for the very first time on Zoom. So if we have two participants, what we've done with the Keybase server, that Zoom key server, is we've taken that multimedia router out of the initial handshake between the two participants. So when Alice and Bob want to meet, they no longer have to go into that multimedia router to meet one another. They go to the key server and they say, hi, we'd like to make a connection. And that key server simply is an introducer of the two endpoints. So Alice and Bob meet, and now what happens is they exchange cryptographic keys using that multimedia router as a forwarding agent, but the multimedia router has no visibility into the packets that are being exchanged. And when this is completed, we now have established cryptographic keys at the endpoints, allowing us to exchange audio and video and screen sharing in a cryptographic fashion so that no one that sits in the middle has any access to that data. And this was critical for establishing trust of what Zoom was doing for meetings. If we want, we're going to go into a lot more information and a lot more detail on this. Max is going to walk you through some of the details and how the keys are exchanged, and then how we're using this to leverage and move this out to the endpoints of users sitting behind the Zoom infrastructure. So again, with end-to-end encrypted meetings, we've established trusted identities of the Zoom binaries. We know that when we set up our meeting, that nothing in between has modified the cryptographic key exchange and data is going end-to-end. But that really starts to beg the question, what about the trusted identities for the actual users that sit behind Zoom? How do I know who I'm talking to on the other side of the screen? And this is really where we moved into this conversation with Okta. So in every single Zoom meeting, there is a green shield in the upper left corner. That green shield will tell you if this meeting is encrypted end-to-end or if it's encrypted with enhanced encryption. And what that is this is a way for us to establish that the Zoom binaries have connected securely and that we can be confident that the data is being exchanged with an encrypted way. With this project with Okta, what we've done is we've extended this concept and we want to represent trusted IDP identity for the end users. So we want to say, hey, listen, I know that my meeting is encrypted, but how do I know that I'm talking to the right person that's sitting behind the screen? How do I know that this guy on the right is really who he says he is? And how does he know that he's really talking to the right guy? And this is where Max is going to go into some of these details and talk about how we can start to assure that we're really confident that we are who we say we are when we communicate on Zoom.
Thanks, Rod, for that. I'd like to go into a little bit more detail about how Zoom is building out end-to-end encryption powered by strong real-world identities. Our goal here is to expose real proven identities into Zoom meetings. In the screenshot, you can see Casey has this feature enabled, and he's presenting to the rest of the world. He is Casey at Cypress.com. There are two reasons why we think this is really important. First is we see an increasingly virtual only or virtual first world. And in a virtual meeting, you're missing a lot of cues you might have in a physical meeting that give supporting details about identity. So if Henry and Casey are meeting in this digital meeting for the first time, there might be doubts about each other's identity. And this is where cryptography can really help out. And in a more subtle point, in anything that's end-to-end encrypted, there is always the opportunity for something called an MITM attack. And we'd like to go into this in a little bit more detail. So what is MITM? It stands for man in the middle, or if you read our white paper, we call it meddler in the middle. And the general setup of the attack is this. Henry thinks that he is handshaking with his friend Casey, but instead he is connecting to a malicious third party named Eve. And Eve is going to do a fancy dance where she is taking some of the information from Henry and sending it over to Casey, and then sometimes she'll inject her own cryptographic information. The end result of this intrusion is that now Henry is talking to Eve, and Eve is relaying that data to Casey, but Henry and Casey are none the wiser. Eve gets to listen in on the whole conversation. This potential for man-in-the-middle attacks is really the scourge of user-friendly end-to-end encryption. And if you look at Zoom's released end-to-end encrypted product, we ask that people in end-to-end meetings perform a not very user-friendly protocol where the leader of the meeting might have to read out a whole bunch of codes and the participants of the meeting might have to check in their UIs to make sure they're seeing the same codes. We think in practice a lot of users might skip this, and if they do, they might be vulnerable to meddler in the middle attacks. So the question becomes, can we provide strong guarantees here with good user interface, even without trusting Zoom servers? And our strategy for how to move forward is to move trust from Zoom servers onto a trusted third party like Okta, and in particular, its IDP product that is often used in concert with Zoom. And so why is Okta the right partner here? Well, if you think about Zoom's customers, and they can be large banks or multinationals, those who use Okta are getting a lot of nice guarantees. They get the fact that Okta knows the roster of their organization. So Okta knows who got fired, who got hired, who's allowed to be advertised as a member of this organization. Okta knows also how to authenticate these users, and they know how to authenticate them in a way that Zoom cannot interpose on. And so this means that users of Okta can authenticate in such a way where they don't have to worry about Zoom potentially corrupting the integrity of that authentication. And finally, we chose to work with Okta here because we realized they're a fast-moving and innovative partner who was very eager to expand the boundaries of end-to-end encryption as we were in building out this product. So just to summarize what I want to speak about today, I first want to go over how Zoom encryption worked prior to October 2020. I then want to go into a little bit of detail about how we changed Zoom's meeting product to enable end-to-end encryption. And finally, I want to talk about our future plans for improving this to bind identities with long-term keys using Okta in such a way to provide better guarantees for end-to-end meetings. And also, I'd like to discuss a little bit about the implementation details that we've discovered in order to make this key exchange a reality. So first, let's go over Zoom's standard encryption. Let's just say there are two users, Alice and Casey, who want to use Zoom meetings. Prior to October 2020, here's the way things worked. Alice and Casey would both connect to an MMR server that Rod mentioned earlier in his presentation. The MMR would generate a 32-byte secret meeting key. Alice and Casey would connect over TLS to download this secret meeting key from the Zoom servers, at which point all three parties, but no one in the middle, knows this meeting key. This allows Alice and Casey to encrypt meeting audio-visual streams as well as screen share data in such a way where neither of their internet service providers or ISPs can snoop on their connection. Moreover, if you think about this arrangement, it means it's also the case that Zoom servers do have a copy of this meeting key, and this is an important feature if Alice and Casey want to use some value adds that are available in Zoom meetings, such as Cloud Meeting Recorder or PSTN dial-in. In the case of both of those features, Zoom's MMR will have to decrypt and re-encrypt data sent to and from those third parties for the benefit of Alice and Casey. And so in that case, there is a strong use case for the server to know the meeting key. If Alice and Casey are not using those features, then this meeting key can be ignored by the Zoom server after the key exchange. The question is, can we provide a better security guarantee than just trusting the Zoom server to not use this meeting key in a way it shouldn't? And the answer is yes, and we rolled out the end-to-end extension to Zoom meetings in October of 2020. And here's the way this new protocol works. Alice and Casey connect to Zoom servers, and the first thing they do is they get copies of each other's long-term identity certificates. So Alice gets Casey's certificate, Casey gets Alice's certificate. And these certificates correspond to each of Alice and Casey's long-term devices that they use with Zoom. With these certificates in hand, Alice and Casey move on to the next step of the key exchange protocol. Alice now, and not Zoom servers, will generate a 32-byte meeting key. This is the symmetric meeting key that Alice and Casey are going to use to encrypt all their data. Casey, on his side, is going to generate a one-time use ephemeral public-private encryption key pair. He's going to sign the public side of this key pair and send it over to Alice through Zoom servers. Alice is going to verify Casey's signature using the certificate that she got from Casey earlier. And if she's happy with that verification, she's then going to make an encryption of the meeting key, encrypted with Casey's public key, and signed with Alice's long-term identity key. She's going to send the signed encrypted package over Zoom servers back over to Casey, who's then going to do the opposite. He's going to verify Alice's signature on the package. He's going to use his private encryption key to open the encryption and then recover the secret meeting key that Alice and Casey are going to use for this meeting. And now we're back to where we started in the simple encryption case. Alice and Casey both have a copy of the meeting key. However, Zoom servers does not have a copy, and therefore, Alice and Casey have a stronger notion of security for their end-to-end encrypted meeting. They will go and encrypt their AV data and their screen share data using the shared meeting key, just as they did before. Well, the system seems pretty ironclad. What could go wrong? Well, I skirted over an important detail, and that is when Alice and Casey at the beginning of the exchange these certificates, they're really trusting Zoom to deliver the right certificates. And what if Zoom is compromised and delivers the wrong certificates? In particular, Zoom could deliver Eve's certificate to Alice or Casey, which would allow Eve to perform a meddler in the middle attack, like I described earlier. This is where our partnership with Okta comes into play. Alice, when she gets Casey's certificate, can do better than just trusting Zoom. She can get from Zoom a signed statement about important pieces of Casey's identity. In particular, she can get a statement that includes Casey's public keys that correspond to all of his devices, Casey's identity, and in this case, the identity is an email address. So we have casey@cypress.com is Casey's email address, and the company is cypress.com. And you can imagine cases in which these two things disagree, but for the purposes of simplicity, we're going to say that the email domain and the company domain are the same for Casey. And because Casey and Alice already trust Casey's IDP to speak on behalf of Casey, this statement can be signed by Okta and signed in such a way where Zoom or any intermediary cannot interfere or cannot forge the contents of the signature. When Alice receives this signed statement that's been signed by Okta, she now has a much stronger guarantee that she's talking to Casey on the other side and not somebody pretending to be Casey. As such, she might be justified in showing Casey's identity on her meeting UI so that Alice knows that she's talking to the right Casey and with an identity that she can recognize. So this is the end-to-end experience that we hope to achieve. Let's drill in a little bit deeper to figure out how we're going to get there. So Zoom worked closely with Okta to make an extension to the OIDC protocol for the purposes of end-to-end encryption. And here's what this might look like in practice. Before Casey ever gets into a meeting, he'll configure his relationship with Okta for the purposes of end-to-end encryption. So the first thing he'll do is he'll go through a standard OAuth 2 authentication flow. This is the flow you see all the time when using an SSO. You might enter your username and password and then answer a push notification to make sure it's actually you. Okta, happy with this authentication flow, will send back an access token, which Casey now can use to prove to Okta later that he is Casey and he's been authenticated by Okta servers. In the next step of the flow, Casey will ask Okta to update its identity information that it can publicly reveal to other chat partners about who he is. In particular, he'll tell Okta, I have two devices, a desktop and a mobile phone, and here are their public keys. The access token is Okta's way of making sure that Casey is saying this and not someone else pretending to be Casey. Okta can then send back a signed attestation. And the attestation will have all those important components of identity that we spoke of earlier. It can have Casey's public keys, it can have his email address and his company, all signed by Okta. Now when Casey wants to join a meeting, the flow works like this. He'll post to Zoom server a copy of that public identity attestation signed by Okta. Alice, when she joins the same meeting, will download that same identity attestation. And she'll look into it and say, this is Casey's identity as given by Okta, but there are a couple things that I want to double check. In particular, Casey has claimed to be a member of this company called Cypress.com, but is Cypress.com aware that Casey is claiming this? And is Cypress.com actually using Okta as its IDP? Well, Alice can answer these questions by asking Cypress.com directly. She can make an HTTP GET to Cypress.com. Cypress can return Alice's request with an affirmative, in particular, giving Alice more information about where to find Cypress.com's IDP. This is, in effect, a redirect to Okta's infrastructure. Now Alice can ask the IDP for Cypress, what is the public key you're using, and how can I verify that the attestation sent back by Bob in step 2 is actually a legitimate attestation. So now she has all the pieces. She has the attestation, she has the public key that Casey originally used when he joined the meeting, and she also has Okta's public key to verify the fact that Okta is claiming all these pieces of information are bound together. So given that she's able to verify it and that all these checks actually work out okay, she can now feel confident about displaying Casey's name in her meeting UI. And so at the end, Alice will wind up with a UI that looks a lot like this, that Casey at Cypress.com, as proven by Okta and as provably delegated by Cypress.com, is attesting to the fact that this is Casey who Alice is talking to, and Casey using the right public keys. And therefore, she has a very good guarantee it's actually Casey and not an attacker like Eve pretending to be Casey on the other side. She can feel really good about this meeting. So that's some of the details about our end-to-end encryption and how we integrate it with Okta. I want to kick it back over to Rod now to go over some of the high-level strategy we think all of this is a smaller piece of. Thank you.
Thanks, Max. One of the things that I want to talk about is this concept of moving data from an ephemeral state to a persistent state. What that means is over the last 12 to 18 months, what video conferencing has represented to people has fundamentally changed. Initially, it was typical to create a Zoom call, bring it up, have a connection, and then to drop it, and then go about and do the rest of your work. But as the world changed, there became a need to persist this data and to hold on to it because we're building on this for workflows. What that meant now is that we need to now create more trust on top of this information and make sure that we really know who we're talking to and that we can really be confident that the infrastructure that we're running through is not modifying that data. A lot of the concepts that Max just spoke about. So this movement from ephemeral to persistent is really fundamental in what we're doing with trust creation. Trust effectively is is the person or the thing that sits on the other side doing what I expect it to do. And here, let's go back to the initial kind of our mental model of what a Zoom call looks like. So I would say that this is a very, very accurate representation of what people thought and what people were doing on Zoom maybe 12 to 18 months ago. But I think the better way to think about it is that we're really transitioning into a new world here. And this concept of Zoom being more of a graph and being this very interesting web of connectivity. And this web of connectivity is opening up all kinds of opportunities for information sharing, information capture, and really starting to build on top of data in this platform that Zoom is trying to create. And in order to do this, we need to know who we're talking to, who we're trusting. Is the infrastructure that's connecting everything together trusted? Are the endpoints trusted? And should I be giving up this information and this data to the other side based upon who I know and who I think they are? This is the direction we're moving. This is the momentum that we think we're gaining. And this is the direction that we've taken this project with Okta in order to create value for Zoom, Zoom's users, and the entire capture of the platform that Zoom is working on. And that concludes our talk. Thank you very much.